Okay, so today we got medium problem 8 for 6 hand of straight. So Alice has a number of cards she wants to rearrange so that we have groups of group size and they have consecutive cards, and we got the hands and return true false. So first condition I immediately think of is that group size needs to divide size of hand. Otherwise, if that doesn't happen, we are cooked. Now if that happens, right, I mean, we could technically sort these and then you know, go through the list and then put into I guess, you know, or we could just, you know, put this into a like a multi-set or not, or like a set of pairs, right? And then we decrease counts and remove those that have count zeros, and when we get group size we go again, so this way it's n log n. Now can we not do this faster? Like let's say we keep counts of elements, right? Because and just iterate over here, and we are like, okay, 1. Well, if we find 1, then it should be in some consecutive size of elements which are divided by group size. So we extend to left, we can first we go through it and we keep counts of elements, right, to know what elements do we have, and then we go to left to the number, right to the number, and then we get the range. If the range doesn't work out, then we are cooked. Otherwise we also decrease the count for each number there, and then we move on, right? And now because okay, we would decrease, like here we would decrease what, 1 2 3, right? But when we come to 2, you know, it doesn't matter that we technically picked 1 2 3 here. Wait, 1 2 3, no, this will not work. But this has to be doable in linear time. So, well, the problem with this will be that exactly on this input it wouldn't work, because I would take 1 2 3 4 and immediately it doesn't work and we are cooked. Well, that one has to be part of something, right? Because let's say first element would be 3, right? How you can go 1 to there, 2 3 there. Well, imagine that we go to left side, right? And there will be like counts of numbers will be 2 to 2, then 1, and then again 2 to 2, right? So do we really want to go over that boundary? not so sure. So let's say we got okay, either way we get this huge continuous blob of shit, right? And then how do we deal with that shit in O1 time? Or ON quite easily, because once we have it sorted, then we put pointer at the start, right? And then we decrease the counts for the group, and until that first one is non-zero, if we can even do that, right? Could have some sort of prefixes, because imagine we have this, like we have a 1, 2, 3, 4, 5, 6, 7, 8, right? And then the counts are like 1, 1, 2, 2, or like 2, 2, 2, 1, 1, 4, 5, 4, right? And then we'll have some prefix sums, right? And this will do like we do -2 here, right? At first, right? And then we will not do anything here, right? And then suddenly we do +2 here. Each time we will have to check if we are, because let's say group size would be 4, right? And then we accumulated -2, and this is fine, this is fine, this is fine, and now we get to minus here, so we are cooked. Right, so going to CPP. Let's call it card, right? Okay. Once we have that, we go for auto card and I could call this int, why not? Now if count of card is 0, then we continue. Otherwise, we do this int l is card while count of l minus 1 then l minus minus count of r plus 1 r plus plus. Great, so now we got the range, and now we want to do this. We need to have some sort of a prefix count. Then we do this for int I is ri plus plus. And then what I want to do first, I want to check if prefix I, no, if count I larger than if count of I plus prefix I under 0 return false. That was exactly the case we talked about. And now we want to do cent I minus equals or plus equals prefix of I, and then if count of I is over 0, then we want to subtract, so prefix I prefix of I plus 1 minus equals count I and prefix of so then if I plus group size over R plus 1 return false, so that goes outside the group, and then I plus equals count. Maybe this will work, I don't know. So this somehow worked, this didn't. Okay, so card 1 from L to R, right? And then so let's see this. So 110, and then I okay, so there's some bug because we should also subtract 1 from there. Oh. That doesn't work out because I just update the window, but I somehow want to push it. Okay, so I think what's happening is that I'm not pushing the prefix for some reason. Is this really true? Because I should do this, and then I should update this prefix, and then maybe this. I'm not sure. Where is the false exactly? Because I'm kind of clueless here. So, well, the prefix is 0, right? I don't have to write it out. So the first one and because what about this? So first I'm at I, right? And now this prefix is nothing, right? Okay, so when I'm at second number, this is the prefix, right? And at third number, this should be the prefix. Like this, maybe. Maybe this. Bunch of zeros. Okay, after second one, after third one, it looks like this. So there should be -2 here, and then what? That doesn't make sense. where do we stop? So after prefix. So what's up with that? So output prefix, first 5 prefixes, so count 8. I'm doing something wrong. Should be our +1, so we actually go to the next element, right? And then do this. Okay, and then solve this. I don't know. Well, at position 4, I mean, you really should be interested in still do -1. So maybe this. Oh, okay, magic. So magically, I think what happened is that we have ON solution right now. Not sure, but yeah, okay. It's very slow for ON, but fair enough, I guess. Okay. Let's see what the editorial says. Optimal. Optimal and most optimal. What is that, bro? What is that, bro? What is this? So you do counter, start count, okay. Okay, Jesus, blah blah blah. I mean, that's very much simplified, but whatever. I mean, optimal, most optimal is. So how is approach to ON? let's just, okay, so let's write if sum on. I mean, I guess it's simpler, but who cares? So I don't know how to call this. Linear or like continuous. Okay, so now we sort the elements. Can we then let's assume the elements are sorted. Let's assume the elements are sorted. Can we find the groups in ON? If yes, can, or let's use how to find the groups in ON. Okay, do we really have to sort the elements? Can we not get the sorted in linear time? So question 1 or answer 1. Oh, it's quite straightforward. We simply mark the first group size consecutive elements as used, and then find and then move in the end until we find the first unmarked and repeat. Now let's compress the end into unique. Okay, compress the end by the card number, e.g. 1 2 2 3 1 1 2 2 3 1. Then we simply decrease count of first group size elements until we can't, or we until we can't. All counts are 0 or invalid hand. Then we move the start of the hand until we encounter a number with non-zero count, and repeat until there are no more numbers left. You might think this is ON squared, but so let's say we remove the first group size elements, right? We do that bunch of times and then we move on, right? So we iterate over all the removed elements. Is iterated over only count plus 1 times, where count is the number of times it appears in the initial hand, and plus 1 is for iterating to the next element. Answer 2, no. We just go through the hand elements, and when we encounter a card which has not been placed into some group, we simply find the we create number left current card and decrease it until there is a card, until we find until there is such unplaced card. Similarly for right current card. Okay. Suddenly we have the exact sorted segment. Segment from the previous answer. Now, notice that each element is only iterated over count plus 01 times, so the time complexity is still on since we have to keep counts of elements. use a funny prefix, some solution to avoid some but it has a larger constant